Hi, I'm Derek. Welcome to Tech Edge. If you're responsible for the data at the heart of a manufacturing facility, you eventually hit a crossroads. Do you stay within the walled garden of a proprietary supervisory control and data acquisition ecosystem, or do you build a custom architecture? One offers simplicity, the other offers flexibility and data sovereignty. We've covered what SCADA is and how it works in a previous video, link in the description, but today we're going to compare proprietary SCADA systems to custom-built solutions and look at the hardware considerations you need to master if you decide to take control of your own data architecture. Let's dive in. Let's start with the facts. A proprietary SCADA system, the buy option, is designed to be a turnkey experience. The vendor provides the software, the controllers, and the support. The advantage? It's a single point of accountability, and it's often faster to deploy because the integration work is done for you. The trade-off? You're on their roadmap. If you need a specific I/O configuration they don't offer, or if their lead times slip, your project stalls. Plus, there's the software tax to consider, which comes in the form of recurring licensing fees that can be significant, particularly as you scale. On the other side of the coin, you have the custom or open architecture solution, the build option. This is where you pair industrial hardware with hardware-agnostic software like Ignition from Inductive Automation. The advantage? Total strategic agility. You own the hardware, you own the data, and you can scale without being penalized by per tag or per device licensing fees. You can choose the exact physical form factor for every point on your line. The trade-off? The integration responsibility is on you. You have to ensure the hardware and software are compatible and that the physical specs meet the environmental demands. Every situation is unique, and your project goals and circumstances will dictate which option makes the most sense for you. But in our experience, a more custom open architecture approach offers a lot of short and long-term advantages for many businesses. If you decide that a custom open architecture is the right path for your facility, your next step is identifying the right tool for each job. In a SCADA environment, hardware often falls into three categories: the gateway, the server, and the HMI. Let's look at each one, what they do, and more importantly, what you need to consider when choosing a hardware platform. The gateway is your boots on the ground. Its job is to live near the machinery, collect raw data from sensors or PLCs, and translate it into a communication protocol your SCADA software understands, like MQTT or OPC UA. Because these gateways are often tucked away in cabinets or mounted directly to machines, they may have to survive in suboptimal conditions for technology. Here are your key considerations for SCADA gateways. First is physical connectivity. These devices are your IT/OT bridge. You'll want to ensure the system has native integrated I/O. Look for multiple LAN ports for network redundancy and serial ports to talk to legacy PLCs without relying on unstable USB adapters. Next, you'll want to consider thermal and environmental resilience. Most control cabinets are uncooled and prone to dust buildup. You need a fanless solid-state design. A fan is a moving part that will eventually fail in a manufacturing environment. A fanless chassis acts as a heatsink, significantly increasing the system's mean time between failure. Finally, there's power stability. Manufacturing floors are electrically noisy. Look for hardware that supports a wide DC power input range, typically 9 to 48 volts, and features protection against voltage surges or drops, as well as protection against interference from the plethora of wireless signals bouncing all around your facility. Moving to the next type of hardware, the server is the brain of your SCADA system. It's responsible for the heavy lifting, running the core SCADA software, managing the historical database, and handling complex analytics. While some facilities leverage the cloud here, many require an on-premise server to ensure low latency and 24/7 uptime, even if the external internet goes down. Edge servers are becoming critical infrastructure for effective data management, but not all servers are well suited for industrial applications. Here's what you should know and keep in mind when it comes to SCADA servers. First, you'll want to consider compute density versus environment. Standard rack servers require a climate-controlled data center. If your server is living on the factory floor at a remote facility, you need an edge server. This means high core count CPUs and high capacity storage, but housed in a chassis designed for higher ambient temperatures and vibration resistance, as well as a few key features, including remote management. Once your edge server is deployed, you don't want to have to be standing in front of it to check its status or make adjustments. Look for hardware that supports IPMI or similar out-of-band management tools so your IT team can monitor health and service systems remotely. You'll also want to think about expansion and scalability. Your data needs will inevitably grow. You'll need to ensure the server has enough PCIe lanes for high-speed networking cards or additional storage controllers so you aren't forced to rip and replace in 2 years. Finally, there's the HMI, or human-machine interface, where the data becomes actionable for your operators. This is the most visible part of your SCADA system, and because it's a literal touchpoint, it's also a potential point of failure. You can opt for a separate computer and display here, but often an all-in-one panel PC is the most convenient solution. Here are some things to consider when you're speccing out your SCADA HMIs. First, there's ingress protection, or IP rating. This defines how well the unit is sealed against particulate and liquids. For example, an IP65 rated front bezel can handle dust and low-pressure water jets. If your line requires high-pressure washdowns, you'll need to look for even higher ratings or dedicated enclosures that those systems can be installed in. Next is touch technology. Not all touchscreens are created equal. Resistive screens are pressure sensitive, making them ideal for operators wearing heavy work gloves, while capacitive screens work similarly to your smartphone and allow for multi-touch gestures. Finally, there's mounting and integration. How will the touchscreen fit into your facility? Look for VESA or panel mount options that allow for a seamless flush installation into existing control enclosures or swing arms. The space you have to mount will often inform the size of the screen, so make sure to consider where it will go and what it will need to display before settling on a screen size. Lastly, if your environment gets a lot of direct sunlight, be sure to consider the maximum brightness of the display. So that's a high-level overview of SCADA hardware. We've really only scratched the surface of what you'll need to think about when it comes to your SCADA deployment, but identifying these requirements is a big part of the process. Once you know the what and the where, choosing the hardware becomes a lot simpler. Still have questions? Our team is here to help, so be sure to connect with us at onlogic.com. If you found this video helpful, we'd appreciate it if you gave it a like, and would love it if you considered subscribing. Thanks for watching, and we'll see you next time on Tech Edge.